This lesson introduces a related and dependent design problem, the log files. On the original single virtual machine solution, all of the log files were stored on the instance. As the design changes, new complications are introduced into the design of the log system. To meet troubleshooting requirements, the separate logs will need to be aggregated onto a single system. Watch the lesson that describes the problem and then come up with your own solution. When you're ready, continue the lesson to see a sample solution. Remember that the sample solution is not the best possible solution, it's just an example. Your design might be better.
Now it's your turn. So we've got a design challenge, log aggregation. Here's our situation. When we were logging data for the log files for the thumbnail service, we were storing the log files on the local machine. Now, what do the log files look like? Well, they are given an ID for the log entry. They're given a session ID. That was very useful to be able to determine if we can map it to a user. Here's the timestamp and then a payload, information about the application on what's going on. This included both the web and the processing component, so we could easily troubleshoot. Well, now what's going on? Now data is being segregated, right? So for proper troubleshooting, the segregated log files have to be joined. That web server and that application server are now processing logs on their own devices. So we have to somehow aggregate these log files. So what that means is we have two different log entries now, one for the web and one for the application. They do share a common session ID field, so we need to have a process that will join those together for troubleshooting. Otherwise, I'm sure you've tried to look up syslog files with mail log files or something else at the same time. You're trying to match the IDs to find out what was going on at the time. We want a service that's going to help troubleshoot, so we're going to combine the log files from separate locations and join them together into a single log file. So think about this before you move on. How would you kind of do that process? It's kind of hard to have it with invisible students, so we'll go ahead and move forward after this brief pause. Brief pause over, let's go. So in this case, we have logs on two servers. We're going to aggregate them into a single log. So the solution here is to design a logging server. This server will accept logs. Perhaps we're just using syslog, Fluentd, or something else like that. Maybe even Kafka, right? So in this case, we're going to create, let's call this a Python script. We're just going to whip something together. We're going to have a daily cron job that's going to take all these log files and it's going to aggregate them. So its purpose is to ingest that data, to append the log files together, so it squishes them together. Then we need to transform them, right? So even though they're all in one file, we're going to transform them and join them on that session ID. Then we're going to output that data, and now we have aggregate log files. And then the daily cron job will go ahead and repeat itself. So every 24 hours, we will have combined logs. Now, I know what you're thinking. Wait a minute, that could be a real problem. My logs are 24 hours old, but guess what? The service really isn't that important, and it was a quick fix. That's how we solved the problem. So here's our new business logic. Our goal here is to match the session IDs together and append them together. So you can see here we have a simple transform process. So now we have a single session ID with both the timestamp and the payload, and the timestamp and the payload for our app logs and web logs together. So this makes it very transformative. Now the timestamps could be different, which could indicate latency, etc. between the processes. So that's why we have that. So think about this, because this is going to be very important, especially in later modules, especially around sizing in general. All right, so here's our output log. Here's some of the numbers to get familiar with. We're going to have 25,000 records per day. The payload for A and B records now has a maximum size of 256 bytes each. This will be important when we get into sizes. Right now, this isn't too bad, so we're okay in storing this on a single server. So this gives you the measurements, which we'll be utilizing in some future design and process.